Okay, so for question 13, we are being asked to find A1, A2, T1, and T2. We know that the rope has a mass of 0 and has no friction. The first thing that we do is we start to evaluate what our values are, what we can work with, and what we start by using the equations that we know we're going to use. T minus mg equals m a. Consequently, we could do T1 minus M1 times G equals Mg times A. And because we need to go ahead and create a formula to get all of our values. A1, A2, T1, T2, as well as we can use gravity for this equation. So we start with M2 times G minus T2 equals M2 times A would be for our A2 and my D2, the blue equation, radius. So we begin to use the systems, and we have M1 equals T1 minus M plus G equals mg times acceleration, as well as for our 2, we would have M2 equals M2 times gravity minus T equals M2 times acceleration. So we know that our equations for M1 and M2 are going to be the same. They're going to be equivalent. So we can gather from that T1 and our T2 are going to be the same. Once we know that, we go ahead and we combine our equations. And so we're going to go ahead and combine our M1 and our M2 equations. So we would get M2 times G minus M1G equals M1A plus M2A. As we simplify the condensed equation, we end up with acceleration is equal to M2 minus M1 times G divided by N1 plus M2. So in order to test our theory, we're going to go ahead and grab some values. So we're going to put for M1 that it's going to be 10 kilograms, and M2 is going to be 100 kilograms. And at the beginning of the video, I should have mentioned that M2 is greater than M1. Due to how the diagram is provided, it looks like we're getting a higher value for M2. So we're going to go ahead and plug in our values, and we're going to get acceleration equals 100 minus 10 times g divided by 10 plus 100. Once we further simplify, we get our acceleration is going to be equal to 18.18. So now that we have our acceleration, we can go ahead and plug it into our t value so that we can get T1 and T2, since we know that we've proved earlier that T1 is going to be equivalent to T2. So we just have to do it once, and we're going to use the equation T1 minus mg was ma. So we're going to make everything positive. We're going to go ahead and move the energy to the right side of the equation. So we could have positive values, and we're going to plug in all of our numbers, which would give us, for T1 as well as T2, it would give us 181.8. Okay, that's all for this problem.